In this video, I want to have a look at what's called the least squares line of best fit. So in one of our earlier videos, we had a look at drawing a line of best fit by eye, and we figured out that it's not the most accurate way to do it. So in this video, we're going to have a look at finding the equation of what's called the least squares line of best fit. Sometimes it's also called the least squares regression line. The formulas that we need for this are on your formula sheet. So at the top there, if we just have a look at the first bit of it, it says y is equal to the gradient times x plus the y-intercept. So that's a long way of writing something that we've already looked at. When we looked at the equation of a straight line, we always wrote it as y equals mx plus b. So that m was our gradient, like it says here, and the b was our y-intercept, just there. So it's the same thing, just written a little bit differently. But we need to know how to figure out what the gradient and the y-intercept are. So we're given some formulas for those as well. So our gradient is going to be r, which if you remember from a few videos ago, that's our correlation coefficient, times the standard deviation of the y-scores divided by the standard deviation of the x-scores. So we're going to need to find correlation coefficient and the standard deviation of both our sets of scores. So that'll give us our gradient. To find the y-intercept, it's going to be y with this bar above it. That means the mean of the y-scores minus the gradient, which we've just figured out up here, times the mean of the x-scores. So we're going to have to figure out 5 things in total to be able to do this. So this whole thing is given to you on your formula. The 5 things we're going to need to find are that correlation coefficient, the standard deviation of the y-scores, and the standard deviation of the x-scores. On your calculators, those buttons will look like this: standard deviation of x and standard deviation of y. We also need to find the mean of the x and y scores as well. Let's have a look at an example of that. Our example says that 12 students have measured the height of their belly buttons and the length of their right foot, and we've got all those numbers in the table. So this example is going to step out each thing that we need to find and then ask us to find the equation. So the first one it asks is for the correlation coefficient. So on your calculator, we've done this in one of our earlier videos, but you can put it in statistics mode. Because it's bivariate data, we want that one there. Now that x column is going to be our belly button heights and the y column is going to be our right foot lengths. So you can enter all the belly button heights first and then come back up and do your foot lengths. So let's enter those in. Then back up to the top and across to do your foot lengths. Beautiful, and we've got those 12 data sets entered in there, which is what we wanted as well. So we'll hop out of there and we need to get the correlation coefficient. So we're going to press Shift, number 1 to get that stats mode. And then we've got 5 and that R there, so 3. Then equals. So it's asked it for to correct to 3 decimal places. So that would be 0. R equals 0.540 to 3 decimal places. Alright, to find the mean and the standard deviation, all of our data is already in there, so we don't need to do anything just yet. So we don't need to re-enter anything. We just need to be able to figure out our mean and standard deviation. So we're going to go back into the stats mode. We're going to go into this one that says variance. So that's where all our means and standard deviations are. So you can see here we've got the mean of the x scores. 3 is the standard deviation of the x scores, 5 is the mean of the y scores, and 6 is the standard deviation of the y scores. So in ours, because the belly button's on top, that's our x scores, so that's what we want to do first. So if we go the mean of the x scores, we'll press 2 and equals, and it'll give us 101, and we want it to 3 decimal places. So that would be the mean, is 101.833. And the standard deviations, we'll do the same thing again. We're going Shift 1 and then into variance, so 4. And then we want the standard deviation of the x scores, so that's our 3. So that's 6.216. So the standard deviation of the x scores, 6.216. So we're going to do the same thing for the y scores now. So we want the mean of the y scores. Again, we're not re-entering any data, we're just going back in here into number 4 where it says variance. We want 5 for the mean. So we've got 25.583. And our standard deviation for our y-scores is 4, and then that's 6 there. And we've got 2.957 once we round it. So 2.957. Okay, so now we have our 5 pieces of information that we need to be able to use our formulas, which were back on that first page. So we've just got a little version of our formulas here. So we've got, if we move that out of the way, we found our 5 things. We now need to substitute them in. So we eventually want to get to this. We need to know what our gradient is and our y-intercept, which means we need to use the second and the third formulas to figure those things out, and then we can plug it into that top one. So let's go through and find the gradient first. So the gradient is going to be equal to R, which is our correlation coefficient, so that's 0.540, times the standard deviation of the y-scores divided by the standard deviation of the x-scores. So the y-scores was that 2.957 divided by the standard deviation of the x was 6.216. And then we're going to pop that in the calculator. So we'll have 0.540 times 2.957 divided by 6.216. And we'll end up with and let's round this to 3 decimal places as well, 0.257. So that's our gradient. And now we need to find the y-intercept. So the y-intercept is the mean of the y-scores minus the gradient, which we just found, times the mean of the x-scores, which is this one up here. So y-intercept is going to be the mean of the y's, so 25.583 minus the gradient, so 0.257, times the mean of the y's, which was 101.833. And we've popped that in our calculator. So 25.583 minus 0.257 times 101.833. And we'll end up with minus 0.588 to 3 decimal places again. So now we know our gradient and our y-intercept. We're going to use that very top line there, which says y is equal to the gradient times x plus the y-intercept. So we're going to have y is equal to, oops, that's not quite fitting, is it? Y is equal to the gradient, so 0.257 times x, plus the y-intercept, which was a negative, so it's going to be minus 0.588. So that there is the equation of the least squares line of best fit.